All right, so I guess I'll get us started. So thanks for coming to talk about Log4j, one of probably the most interesting software vulnerabilities in over a decade. And interesting is a loaded term because it doesn't mean good. So to introduce myself, I'm a member of the Contrast security team. We focus on application security. I'm in the role of developer relations, which is going through talking about how technology works, understanding people in their environment, how everything fits together, and just being able to put all of the application security pieces together. Why am I qualified to be someone who talks about Log4j in particular? One of the major reasons is I've spent a significant amount of time in the field of Java and application security. So the fact that Log4j is a Java library, that's what the J stands for, it's kind of square in the area of what I understand and do rather well at. So for example, I was a member of the OpenJDK team in about 2013. I had joined that group to deal with the security of Java applets. It was at the time, we had to sunset those. There were a series of vulnerabilities in it. And I was just headlong in Java application security all the time. Beyond that, I'm a tech editor over at a news site called InfoQ. So I publish news in the Java queue that's focused on Java and frequently application security. Similar deal, I'm one of the writers and members of a 4j community, which is Friends of OpenJDK. And I'm also the author of an online course called Applying Java's Cryptography that's available through Pact Publishing, and people seem to like it. So when there's an incident in the field of Java security, I tend to appear and just do a lot to deal with it. So one of the big questions that I have a number of people ask is, why is Log4j so prevalent? Why were there so many things that occurred back in December? Why was it so popular? And we, as Contrast, we just took a look over a lot of the data that we had to figure out where is it, what's the scope of this? Because I, as someone who works in the Java ecosystem, like I see Log4j all the time. So I knew it was extremely popular. I've used it in the past, but I didn't have any real stats in terms of usage. So when we, as Contrast, did a query of how often do we see Log4j, what we encountered is in about 64% of the applications that could have it, which is Java applications, we see an instance of Log4j2, which is the vulnerable version. So when you have something that affects a Java, which is one of the major languages, and you have something that impacts about 64% of the applications on that ecosystem, it's pretty darn big. So Log4j is probably one of the most popular libraries in the ecosystem because it makes logging easy and everybody wants it. But how does this vulnerability actually work? So first of all, this is a CVSS 10, so it's completely unauthenticated, completely remote. And I gotta agree with the people at the Federal Trade Commission that this is a really bad vulnerability. Actually, I forget if it was the FTC or CISA. I think it might have been CISA who said this is one of the worst things they'd ever seen. But that's a pretty good, pretty safe statement to say that it's really bad. So the way that Log4j vulnerabilities work is a Java application will take data that comes from any source, any POJO or plain old Java object, any data that it reads, and they'll frequently log that data. In Log4j, they'll do log.info and then the parameter, and you pass the elements that you want to log. And what happens is if any of your input that frequently comes from remote attackers contains a particularly crafted payload that looks like what I have on the screen right there, where it says JNDI RMI colon, then an IP address with a file at the end of it. What happens is not only will your application log what happened, it'll go and it'll try to download and run the code that I have hosted at that URL. So some of the things that I've seen people do in this vulnerability is they subdomain that location, that URL, to extract secrets. So they'll make you request an environment variable that's actually your AWS key, and then they just look to see which host name you reached out to. They'll get payloads that execute. I have a lot of them that just open up calculator because that's the canonical example of how to test a vulnerability. But anyways, it's really bad for the fact that when your application goes to log something, that you'll also execute code with it. Also, in this case, just earlier in this year, on January 4th is the publication date there, the Federal Trade Commission stepped in to simply warn companies and remind them of the fact that they have regulatory enforcement power. Now, it's relatively rare, and on the commercial sector, it's unusual for a federal agency to step out and simply remind you of the fact that they have regulatory enforcement powers. And in this article, this thing that was published by the Federal Trade Commission, they wrote and they said, by the way, we also did this in the past with Equifax, who we fined about $570 or $700 million, but it's a lot of money. And I've joked with people in the past that the auditor is the ultimate advanced persistent threat because you can't keep them out. I always have questions of how do we block this network? How do we block this vulnerability? Can we block it at the network? Can we just pop up a WAF here? Well, not really in the case of Log4j, because what you have is that network defenses are pretty unreliable because applications just log just about everything. They go to read data from a source, they go to parse an email, they'll generally log what was in that. So this meme was going around the internet in different Twitter circles of a car with a license plate on it. And you see that license plate there is just a JNDI exploit for Log4j that will cause vulnerable instances to reach out and download code from there. Now with ATARC, we're probably already noticing the fact that that's dnslog.cn, which I believe is a Chinese domain. So you've got an entertaining group there in terms of nation attackers. It just happens to be hosted elsewhere. But the reason that this car is particularly funny is we all know how that's going to work if we have ever developed software. You've got some application or library that's going to read that license plate. I've actually written a Java-based license plate reader in the past. There's a library called OpenALPR. It's pretty darn easy to use. So when you read a license plate and you want to see what you read, you want to be able to get that data. So what you're going to do is you're actually going to log whatever you read from the license plate. In this case, you're going to log the exploit payload, which means that your system is going to download that code and run the exploit, and you're going to get taken over. So the reason that this is funny in particular is you can't WAF an image out. You can't go through and put any kind of regular expression in place. You can't really look at the network and have something do rapid image processing because there's just no way to defend this stuff at a network level. In fact, with Log4j, you're welcome to do any network defenses you want, but really the only way out of this vulnerability is by patching it and upgrading your vulnerable instance of Log4j. Now, how did leading organizations patch this quickly? What is it that people were doing in order to patch this when it came out in December and basically blew up everybody's month? I can't say how much time I spent dealing with Log4j, but I jokingly refer to it now as a December to remember, simply because I was doing Log4j just about every day in December, almost nonstop from when it came out. So what people did in order to patch the actual vulnerability, AWS and Microsoft, which are two major software organizations that have a lot of their own software and their cloud providers that run code for many other people, they didn't actually reach for network defenses. They didn't reach for a lot of things that they normally have at their disposal. Instead, both AWS and Microsoft reached for Java-based instrumentation. And they released something called a hot patch for Apache Log4j that would connect to a JVM and simply disable Log4j's ability to download remote code. They stubbed out a class file to give the technical details there. But what that did was it gave them an opportunity to engage an active defense that would take data that wasn't just over the network, that wasn't just at a WAF. So if they had any applications that were doing that license plate processing that we showed before, they would actually patch it and they wouldn't be vulnerable. And contrast in the same way, we released a tool called Safe Log4j. It was pretty neat. It ended up being SD Times Open Source Project of the Week. It worked in a relatively similar way of connecting to a JVM, just being something that sits in the place of a Java process, connects to that application and disables the ability of Log4j to download and remote code and load remote code. Because as I talked with a lot of people in a lot of different roles, both in the Java community and in the CODStress customer base and just everyone out in the general public, there was always a big question of, why is it downloading remote code in the first place? Why would I ever want my logging framework to do that? That shouldn't be happening. So what these patches do is they look for and disable that ability of Log4j to download and load remote code. You can use, if you're still in the throes of patching Log4j, you're welcome to use either of them that you want. The contrast one does some verification on the exploitability using a safe but effective payload in order to test where it's actually vulnerable. So if you're wondering, am I actually vulnerable? We have an agent that can tell that for you. And it's a lot easier to use than just arbitrarily scanning your network. And we dealt with a lot of different people across the way who said, I need to understand and get a handle on where I use Log4j, because if I don't have that, something really bad is going to happen and a lot of my applications are going to be hacked. So one of the features that Contrast, our commercial products, have for our own customer base is a tool that creates an application inventory or software bill of materials, or SBOM, that you've been hearing about in a number of circles from the presidential executive order on cybersecurity. So with Contrast, our tool produces a software bill of materials that a number of customers were able to look at and query and say, do I use Log4j? And if so, where? Where do I have these vulnerable versions? And instead of them hunting around and saying, oh, we got to contact the teams, we got to figure out the application owners, there was just a plain old inventory of all the libraries that made up the software. And you could look and say, I know where my Log4j instance is. And the CISO of cm.com got the answer in about 30 seconds. So major zero-day incident occurs, somebody looks, 30 seconds later, they have a listing of where to go to take a look. And now they know what they need to patch in their environment. Because as I dealt with a lot of people who were just affected in different ways, some in good ways, some in bad ways, some weren't affected, I'm always on the lookout for the commonality of, when things go well, how are people alike in the way that those things go well? Because you have all these areas where we're different, where we have all kinds of differences and everybody struggles. Everybody seems to struggle in their own unique way, but there's a lot of commonalities in terms of things that go well and work effectively. Now, for the people who were able to deal with Log4j really well, they knew where to go. They had that inventory, or at least a partial inventory. They had that software bill of materials. You don't have to be perfect at it. Nobody's expecting absolute excellence at all times, but you at least have a partial SBOM inventory. You have some notion so that you can say, where am I affected by Log4j? That's where I'm going to go spend my time. And then when they were able to go and spend time, the teams were able to either update Log4j for an application that they controlled, or apply a defense to that application, such as the AWS Corretto patch that dynamically patched the Log4j library, or the Contrast Safe Log4j that we've helped a number of people set up. And even once they set it up, the teams where things went particularly well, they did some additional testing just to say, is our controls effective? Are our controls effective? What happens if we launch a payload to this system? Can we verify that that payload no longer gets in, or when it gets in, that it's completely ineffective, which is what should have been happening in the first place. But for people who had a lot of trouble and were struggling back in December, and maybe are struggling now, kind of hoping that nobody notices, what I've noticed amongst them is they don't really know where things are. Applications are just kind of strewn all about. Like, there's a big list of virtual machines, but nobody really knows what's on them, or they have kind of a list of owners, but they don't really know what those people owned. So there's no SBOM or real inventory of what they have for the people who are struggling. Another commonality, I actually saw this a fair amount, and some friends of mine who do development for other companies were kind of laughing about this because they're .NET developers, and they were getting demands. You must tell me, are you affected by Log4j? But because the J stands for Java, the people in the .NET groups are like, well, why are you asking me? Now, it's perfectly fine to ask somebody a question if you don't know the answer. We don't want to assume that things are safe and then be caught later and get in trouble because it turns out that they weren't safe. But it doesn't make sense when you're in the throes of an event and having to deal with an emergency that you'd go out and demand answers from teams that were unaffected and wait for their response. When the J stands for Java, you know that the Java applications are the ones that you spend time with. There's a library called Log4j. If you're a .NET application and that's vulnerable, it would make sense that you'd ask the .NET teams. So what happens is by knowing where to go and taking that crucial time that occurs at the beginning of an event and being able to focus the effort, it made it a lot easier for the people who knew where to go and were able to spend their time effectively versus those who are kind of moving around and just checking all kinds of things. Another technique that was common amongst people who struggle is there was a lot of random poking around. I've heard of a lot of people who were just launching random attacks at different, anything that was basically web accessible. They're like, I'm going to submit random GET requests to these applications to see if anything comes back. Well, that's a perfectly fine thing to do. I'm not going to tell you to not do that because maybe you'll find something. But if an application doesn't respond at a URL or never uses a parameter and never looks at it or logs it, it doesn't matter that you tried to access a GET request at a particular URL because the application never saw it. So you just spent about 5 crucial seconds times 20,000 times that you did it, wasting time doing something that will never have any impact. So the aim is find a way to be effective and know where to spend your time. Here's a quote from someone from Backbase who was just using previously before Contrast a number of tools. They had a one static analysis tool. They had a web application firewall. They had another software composition analysis tool to create the SBOM. And what we help them do is to just take a lot of the tools that they use and unify it in a way that the tools actually work together. So now instead of having all kinds of disconnected tools that maybe each of them is really good on their own, they were able to take all of these aspects, bring them together and get one single view to look at and say, what's the security posture of my application now? Do I have any libraries that are vulnerable? If so, where? And not, do I have any libraries that were vulnerable 3 weeks ago? The question is, are they vulnerable right now? Because when Log4j came out, I think it was on December 9th, any report that you had from December 8th, mark that as secure. But the evening of the 9th, in my time zone at least, that was no longer the case. And all of a sudden there was a massive Log4j incident with a lot of people doing a lot of work. One of the ways that we can help different federal agencies here is you look at the scope of control of what everyone has. And across the federal space, I noticed there's a lot of different types of software. Some groups are developing custom software themselves. Some are buying commercial off the shelf. Others are taking government off the shelf that's built by another department. Some of you might have a series of contractors. And frequently, anyone who wants to defend an organization has a relatively limited scope of control. Frequently, the contractors want to negotiate up front, and then anything you ask them to do later is a change order. So I understand what a hassle that is. One of the things that Contrast offers is our tools work inside of any software, regardless of who wrote it. So if you have custom software that you wrote, that's great. You have COTS, you have GOTS, you have a contractor, that's totally fine. The thing that's common about all software is that all software needs to run. So because Contrast focuses on the runtime, it doesn't matter to us who owns the software, and you're able to have one consistent mechanism for engaging the software regardless of the type of software that it is. Another benefit is it's continuous, so we constantly report it and we constantly monitor that software as it runs, so you can get whatever information you want as it's pertinent and as it's relevant. Another aspect here for anyone who is still in the throes of defending or needs to go through and patch an environment, you're totally welcome to use our safe Log4j tool for free. You don't have to ask us for it. You don't have to pay anything. It's a tool. It's completely free, fully available. You can use it as much as you want, wherever you want. I still recommend patching Log4j because that's just the best defense, but you're totally welcome to use our public remediation tool for as long as you like. Another comment here, the Elsevier team, we did a lot of work. When Log4j occurred, we had a whole bunch of people all across the company just going out in contact with every customer because we didn't want anyone that we dealt with to be caught off guard. So we have a customer success team. You'll find this in a lot of the vendors that you deal with. We engaged quite a number of different groups, just talking to them, telling them what our exposure to Log4j was, which was patched immediately, as well as helping them understand their usage of Log4j. So it was a really nice representation of what happens when there is a major event for everyone to just go through and deal with it and have an actual customer success group, not just kind of wait for the customer tickets to roll in to respond to them. We're pretty darn proactive here, so it's kind of nice for these people to notice. Otherwise, one of the things that I actually like about working in Contrast is we regularly detect zero-day vulnerabilities inside of different pieces of software. In fact, right before Log4j occurred, I was attending a conference called GoVerCon for a virtual conference of Go developers. And I thought it would be really cool to talk about how our tool was able to detect some of the zero-day exploits that were going on in Grafana, or the different vulnerabilities that were occurring in the Go ecosystem. So here we detected a new vulnerability inside of Grafana, and we wanted to show the way that our Go agent was able to detect that. And lo and behold, all of a sudden when Log4j occurred, like the entire industry shifted their attention over to Log4j. So the Go developers were like, thank God that isn't us. That's okay. Otherwise, back at about 2019, we found similar zero-day vulnerabilities in WebLogic and Oracle Application Server that's also written in Java. And one of the neat things about that was when that vulnerability came out, we just did a look and we said, does Contrast defend against this vulnerability? Okay, let's go check that. It did. We didn't do anything. We just ran it on WebLogic. All of a sudden, Contrast blocked it and it said, boop, I'm going to block a remote code execution deserialization vulnerability right here. And we said, oh, this is cool. Our customers have nothing to do because they're already defended from this vulnerability. So it's nice for them to patch whenever they want. And that was a real easy day. So it's always nice when your automated tools are able to detect a number of these 0 days, because it means that you don't have to do a lot of work on that 0 day. You can prepare in advance and it's way easier. Otherwise, some of the reasons why instrumentation is a better approach than network scanning is frequently Log4j is a library that's built and hidden inside of other libraries, not from like a hiding perspective. Nobody's trying to hide it in different areas. It's just libraries are put and combined together, generally through something called FATJAR, a WAR, a EAR, which are archives, or it's shaded inside of particular jars, which means that there's no file you can look at to just say, do I have log4j2, hyphen 2.17.3 here? Because that file doesn't exist. So you can't go and just do a file crawl across a file system because the things that you want to look for won't be there. So you'll get a false negative. So the way that instrumentation works is you actually monitor the code that gets loaded by the runtime. And when the runtime goes to load it, it has to say what it is. So we're able to pick out, is this library loaded at any point rather than just doing a file-based scan. So in the event that your application is plugin based and you download a plugin that includes Log4j, it won't be present in your local file scan, but you still need to find that. And that's part of what instrumentation does, is to detect where things are loaded. Lastly, safe Log4j, I just want to go out and mention that anyone who wants on this call, any peers of yours, you, anyone, you're all able to use safe Log4j for as much as you want, as often as you want. You don't need to be a Contrast customer. It doesn't matter if you pay anything. It doesn't matter if you have a relationship. You don't really need to be a Java expert. It's not a hard tool to install. It's really easy to use. You don't need any special code access. If it's a custom software, if it's GOTS, go right ahead. It'll work for all of those. Pretty easy tool to use. And we're not collecting data on you. It's not some secret tool where we're trying to go and gather telemetry data on anybody in the environment. It doesn't phone home. I guess I should probably do something about that at some point. I don't really want to, though. Like, somebody might ask me. It's not something I want to do. I don't really want to be collecting data about people. And if you want help using Safe Log4j, feel free to ask. Like, we just released this tool in order to help people, so it's available totally free, fully available for anyone who wants to use it anywhere. And with that, I just want to say thank you very much to everyone for attending. And if you would like to see some more information about Log4j2, how the vulnerability works, how people defend against it, feel absolutely welcome to check out any of the URLs here.
Does anybody have any questions?
And if anyone has any questions, also you can put them in the chat.
Hey, good afternoon. This is Kripa Singh from CGI. Are you going to share the deck, whatever we're showing through the email?
Sorry, what about what through email?
Are you going to share the presentation?
Oh, yeah, we can send it out. Yep.
That's good. And do we need to, if someone wants to use Safe Log4j, do they need to sign any MOU or any contract with you guys, or is just to download and use it?
Nope. Safe Log4j is a completely free, completely usable statement. So I don't need to collect information on everybody. You don't have to sign anything. You don't have to fill anything out. Go ahead and use it.
And how many federal agencies are using it as of now?
Sorry, how many what?
Is there any federal agency using this one?
I don't know which of the federal agencies are using it. I would assume there are. It was, I mean, it got picked up by SD Times, so we've had quite a number of downloads. I'm not actively tracking people to like make a list of who uses it. Like, we released the tool because we wanted to help people deal with a massive problem, because it just makes things easier to get people's attention returning back to normal things.
I was asking that question for trust point of view. When you share this information with the team, with the company, that they are going to ask this question, that how we are going to trust this software, that when we are deploying in our environment, that what is going to do behind the scene.
Yeah, so Safe Log4j is an open source tool. If you want to see the code that it runs, you're welcome to look at it. It's actually not very big. It's like easy enough for one person to read. It might take you about 30, it might take you like maybe an hour or so to figure the whole thing out. It's not complex, it's not big. So you're welcome to look at that. But if you want like a full commercial support thing, that's what the Contrast products are for. So they'll do Log4j and a lot more. Safe Log4j we released it to deal with one specific problem, which was the Log4j CVEs.
Okay, thank you.
Yeah, but if it's a hassle for you to deploy software or to get the buy-in for should we use this, I'd take a look at the regular Contrast suite, because you'll get way more.
Okay, thank you.
All right, well, we're at time. It's 2:30. Thank you so much, Contrast team and Eric, for giving us this presentation, and it'll be posted to our YouTube page probably sometime next week, but we really appreciate it. And thanks everyone for joining.
Thank you.
Thanks a lot.
Have a good weekend.